Some interesting points on projectiles. The purpose of this presentation is to show and let us firstly assume a typical projectile. This is the normal x-axis or the level, and then the angle of the projectile is theta with a value of velocity u. And the path of the projectile looks like this. Throughout this discussion, we assume no air resistance or any other resistance. The only force acting is gravity, in which certainly downwards. For simplicity, again here, we denote viewpoint. This is A, the starting point. B is the maximum height in which the projectile reaches, and C is the final point in which it lands. Now, this velocity here can be decomposed into two components. The x component, which is u times cosine theta, and y component, which is u times sine of the angle theta. If we assume that the maximum height, or denote the maximum height, is y, and the maximum displacement horizontally is x. Some important notes. So now this is, or these are all the velocities in which changing all the way throughout the flight. Point number one, the horizontal component of the velocity remains unchanged. So it means throughout the journey, all are the same here. It doesn't change, and it's obvious because there is no force acting in that direction or x direction. But vertically, the situation is different. So the velocity here is the maximum, then it gets less, until reach the top, in which at the top here the velocity is 0. And then after the top, the velocity increases, but in opposite direction as it coming down, and then reach to the level here with this velocity the same as that one. The only difference is the direction. Now the time. If we assume the time of the whole flight is t, this time is going to be the same as the time if an object moves horizontally with a constant velocity u cosine phi, and it is also the same as if you throw an object upwards with this velocity here, reaching the maximum, which is definitely at the same level of b, and coming back to Earth. This time, or these three times, are the same. Mathematics of projectile. So this is the same diagram as we had earlier on to analyze our mathematics. So it means time from A to B is the same as time A to D. And then time A to D here can be easily simplified by, this is the initial velocity u sine phi, and the final velocity here is 0, and the gravitational g is the acceleration in minus. And then you can simplify this time as the following. Then using this equation vertically, which is ut, and here certainly this u is u sine phi minus half at squared, and the reason for minus is again the gravity, which is again the motion. Now simplify this equation for the maximum height or the maximum value of y, then you get this expression, which is very simple. Now horizontally here, so it means the whole distance will be equal to this velocity times time, and then double of this time, definitely, because this time is from here to here, which is the same as that. If you double it, and then because you have got 2 times sine phi times cosine phi, and then you can combine in one single trigonometric. Now maximum vertical and horizontal displacement in terms of the angle. if we assume that we have got few projectiles with the same exactly initial speed, but definitely the angle of the velocity will be different, like those ones in which we have here, then this is the displacement or the horizontal displacement in which this reaches, and this is the maximum vertical displacement in which it reaches. And then now we increase the angle, then certainly the horizontal displacement increased again, and certainly here. Now in the third one, you notice that the horizontal displacement decreased, and then definitely here this is going to be the maximum displacement, and this maximum displacement usually takes place at an angle which is 45 degrees. For vertical situation, it's fairly easy. Definitely it means the projectile has to face fully up, then you can get maximum vertical displacement, i.e. the angle has to be 90 degrees. And both analyses now can be carried out below. Now vertically, this is the equation in which we had it before, and this equation is simply, if you take the differentiation with respect to theta or phi, because this is the only variable in which you have here, you assume the initial velocity or speed the same, and then after some simple calculus, cosine of the angle will become 0 and the angle will be equal to 90 degrees, which is fairly easy, and this is compatible with that one in which we discussed. Horizontally here, this is the same expression as we had before, and this expression here again is function of phi. So if you take the differentiation with respect to phi and equate it to 0 for maximum, and then certainly here cosine 2 phi is equal to 0, and then phi will be equal to 45. And then here I'm not going to talk about to prove if these are maximum or minimum, in which I will leave it for the reader. Then this is quite obvious. By taking the second differentiation and substituting those, you will get accordingly. Cartesian coordinates of projectiles, x and y direction. Now assume that you have got a projectile in the following way, and then this is an arbitrary point on the function. Then vertically here, the function can be represented by this, y equal the initial velocity times t minus half times g times t squared. Then horizontally is fairly easy, because horizontally the speed is constant. So it means u times cosine phi, which is the horizontal component of that, times the time. So now if you combine the two, because this is parametric equation, so these are parametric equation, if you eliminate t from here, you will get the Cartesian equation. Tan phi is constant, g over 2 times u cosine phi the whole square is also constant. And then this is y in terms of x, which can be easily written like this expression as we have in mathematics. And this is the curve representing that function concaving down. Now if you equate y equals 0, you will get two solutions. One of them is obvious, x equals 0, and the other one, which is here, and this is the value of the horizontal displacement as we had it earlier on. Two projectiles problems. So now we assume that there are two projectiles in which projected from the same point at the same time. So now the first case here, we assume that they are projected from the same starting point, and one of them is projectile 1, u1 and phi 1, projectile 2, u2 and phi 2. And then we assume that they meet or they cross at point xm and ym. So now let us see if this can be possible in reality. So the ym can be represented from the projectile 1 direction in that way, which is fairly easy, u1 times sine 1 times t minus half gt squared, the same equation as we saw early on, and this is from the projectile 2. Then horizontally, this is the same idea, u1 cosine phi, because phi 1 is the angle of the first one and phi 2 is the angle of the second one. So now easily we can eliminate t from here, and then this term can be crossed out. You will get to this solution, and then horizontally you will get to that solution. And then if we divide the two, we will get tan phi 1 is equal to tan phi 2. But because phi 1 and phi 2 are smaller than 90 degrees, then it means this equation will give us a solution that they are the same. So it means obviously here, if you substitute it back to the original one, then u1 and u2 must also be the same. So it means here it shows that it is not possible that the two projectiles can meet. Now, the next point here is, if for example they are projected from different points. Now, we treat this in two cases. One of them is vertical distance. Imagine, for example, one projectile is just projected horizontally simply with u1, but definitely here this analysis we talk about is going to be the same if this is projected at an angle. It is very similar. And the second projectile is with u2 at an angle of phi, and then let us assume they meet at the point xm and ym, and then horizontally this is fairly easy, u1 times t, because definitely if they meet after t time, both are, we assume, projected at the same time, and this is reaching here at the same time. So it means u2 cosine phi times t from the second projectile, and then certainly here eliminate t, you will get this expression. Now vertically is the same idea here. Ym from the first one will be h minus this half gt squared, and then you equate to the second one. Once you equate to the second one here, and then simply you can simplify again, and then you reach to that solution. H is equal to u2 times sine phi times t. And then analysis. Then here t can be defined, or can be the subject in terms of that h divided by this u2 sine phi. And then this definitely must be less than the time of the flight of the second projectile, otherwise they will not meet. And then here, if you simplify this, you will get this inequality expression, or can be written in a simple format, h is smaller than or equal to 4y. So now if h is smaller than 2y, the two projectiles meet before the second reaches the maximum vertical height, so it means halfway before. Now the second possibility here, if h is greater than 4y, then definitely there has to be enough space below the level, like what we have here, so that it allows the two projectiles to cross or to meet at below the level. And mathematically this can be even solved, and you can even check that one here. Now the second possibility here is, if for example we have a projectile 1, u1 phi 1, and then projectile, and then at distance s there is projectile 2, u2 phi 2, and then we assume that they meet here at this point. Okay, then again the same idea, ym, the y direction, from the projectile 1 given by this expression in which we had it before, and then the same y from the second projectile, and then obviously these two are the same. Then it means the equation will reduce to the following format: u1 times sine phi 1 is equal to u2 times sine phi 2. Now horizontally, similar idea here, but definitely here from this u1 will be until here, but here For the second one, we need to be careful that we take away s, because this is starting from here. And then at the same type of the equation, and you will get that expression here if you simplify t is equal to this. Definitely this t has to be positive number. Once it has to be positive number, then it means this must be greater than 0, in which means u1 cosine phi 1 must be equal greater than u2 cosine phi 2. Otherwise, the meeting or the crossing at the same time cannot be possible. But definitely here the two conditions, this one and that one, are important here and must hold, but they are not sufficient. The reason is because the horizontal displacement must be in a way in which does allow to cross in here. Certainly this horizontal displacement of the projectile 1 must be greater than this s. Otherwise, the crossing at the same time cannot take place, which is x1 greater than s. Now, more general case. What is more general case? So assume the xy axis or horizontal vertical axis, and this is the first projectile, and this is a point on the xy axis here in which at height of h and distance of at horizontal h and height of s. Then the second projectile is projected from here like this, and then we assume that this is the crossing point, and simply here after similar analysis in which we had previously here, you will get the first condition and the second condition, and on the top of that the ratio between s and h must be equal to that. Then the crossing or the meeting can take place. Thank you for watching.